So we just practiced using the fact that if you want to take the derivative of several functions added or subtracted together, you just take the individual derivatives and add or subtract them. That process does not work for two functions that are multiplied together. You can't take the derivative of two functions that are multiplied together just by taking the two derivatives and multiplying. It doesn't work. So we're just going to do this example to highlight how that doesn't work. So this is find the derivative with respect to x of x times x. Well, we know x times x is x squared, and the derivative of x squared is 2x. So I know the answer is supposed to be 2x. There's no getting around it. That's what the answer is supposed to be. This is the derivative of x times x. So if we tried to use that process, just take the derivative of each factor and multiply them together, we'd have, what's the derivative of x? Is 1. The derivative of x is also 1. And I would just multiply 1 times 1 together to get 2. I know that's not the right answer. The right answer is supposed to be 2x. So it's just a little example to keep in mind, because it's pretty common for a calculus student to try later on during the year to just take the derivative of a product by taking the derivative of each factor and multiplying together. But what really you want to use is called the product rule. So the product rule for derivatives says that if you want to take the derivative of a product of two functions, so here we're calling those two functions u and v. If you want to take the derivative of the product of two functions, the result is the first function without having any derivative taken. Just copy the first function exactly, multiply by the derivative of the second, and then add that result to the second function multiplied by the derivative of the first. So some people in their mind, they say first times the derivative of the second plus second times derivative of the first. Or you can see what I've written here. If you think of the two functions getting multiplied together as u and v, then the derivative of uv is u dv plus v du. So here's an example. I'm going to do a problem where I'm going to take a derivative first by multiplying out a polynomial, and then taking derivative with the sum and difference rule. And then I'm going to use the product rule. We're just going to prove that we get the same answer. And you see you have a similar problem to do on your example page. So here I am. I want to take the derivative of these two binomials multiplied together. So x squared plus 3 is being multiplied by 2x cubed plus 5x. So before I ever knew the product rule, I could do what I did at the end of the last slide set. I'm going to multiply this out. So this takes 4 multiplications, and I get 2x to the 5th plus 5x cubed plus 6x cubed plus 15x. I'm going to combine like terms. So here's my new problem. I want to take the derivative with respect to x of 2x to the 5th plus 11x cubed plus 15x. Well, the 5 is going to come to the front to multiply by 2. That's 10x to the 4th. 3 times 11 to make 33, and the new exponent is squared, so x squared. And the derivative of 15x is 15. So that's what I know the answer is supposed to be, because I know I can use the sum and difference rule as long as I multiply out the polynomials. So try using the product rule. Remember, first times derivative of the second plus the second times the derivative of the first. And what I'm saying here is that the first is the first factor in the multiplication problem. In this case, the polynomial that comes before the multiplication dot that you can imagine in this problem. So here first is x squared plus 3. That's just a copy of this, x squared plus 3, times the derivative of the second. So I need the derivative of 2x cubed plus 5x. Well, the 3 multiplies the 2, makes 6. The exponent comes down, so 6x squared plus 5 is the derivative of the second. And then we have the second function, which originally was 2x cubed plus 5x. We're going to multiply by the derivative of the first. The derivative of x squared plus 3 is 2x. Now, I'm just going to multiply out so I'm just trying to prove that I have the same result. If you wanted to, on the AP test in the free response section, feel free to leave your answer like this. But we're going to multiply it out to make sure we got the same thing. So I'm going to FOIL here, I'm going to multiply out here using the distributive property. I get 6x to the fourth plus 5x squared plus 18x squared plus 15 plus 4x to the fourth plus 10x squared. We're going to combine like terms. And you can see that we get 10x to the fourth plus 33x squared plus 15. So, some people ask, why would I bother to learn the product rule? I'll just always distribute out my polynomials. So, that works for polynomials, polynomial multiplication. You can always multiply out and turn into a polynomial, an addition problem or a subtraction problem. That won't work with other kinds of functions that we're going to learn to take the derivative of. So, you need to learn the product rule. It's one of the most common locations for an error on the AP test, is to forget that if you want to take the derivative of two things multiplied together, it's the first times the derivative of the second plus the second times the derivative of the first.